red warning in Hawaii. Officials warn a major eruption is imminent. Plumes of ash and smoke from the Kilauea volcano up to 12,000 feet above sea level. Wind is carrying the ash as far away as 18 miles.
Beneath the lush tropical canopy and the tranquil allure of Hawaii's islands lies a volatile geological heart. That heart has stirred once more, sending shockwaves, literal and figurative, through scientific communities and local populations alike. The U.S. Geological Survey, USGS, has just issued a rare and deeply alarming red alert following a sudden and dramatic escalation in seismic activity and ground deformation across several major faults in the Hawaiian archipelago, particularly concentrated around the Big Island. This latest upheaval has geologists riveted and residents on edge, as deep fissures have begun splitting open along key fault lines, exposing raw earth and deep magma channels that have long remained hidden beneath the surface. Before we start, smash the like and subscribe buttons for more updates. The red alert, the highest level of volcanic activity warning issued by the USGS, is not handed out lightly. It signals that a hazardous eruption is either imminent or already underway, and that ground conditions are rapidly deteriorating. The first signs came days prior when seismographs across Hawaii began registering swarms of shallow earthquakes, short, sharp tremors that clustered suspiciously around Mauna Loa and Kilauea, two of the world's most active volcanoes. These tremors weren't just random. They followed known fault lines, zigzagging across the island with disturbing precision, suggesting that subterranean forces were not only shifting, but actively tearing open the landscape. As these tremors increased in both frequency and intensity, satellite data began revealing striking ground deformation. Sections of land that had remained geologically stable for decades were suddenly warping, bulging, and splitting. Fissures began to form, at first small and isolated, then longer and wider, yawning cracks that sliced through forests, roads, and even areas near populated communities. Entire ridgelines buckled as if gripped by unseen hands. These weren't typical landslides or surface-level disturbances. The ruptures came from deep within the Earth's crust, evidence that tectonic plates beneath the islands were shifting in ways that scientists had long warned were possible, but had hoped would remain hypothetical for years to come. At the core of this geological drama lies the Hawaiian hotspot, a fixed plume of superheated magma that has burned through the Pacific Plate for millions of years, building the volcanic island chain as the plate slowly drifts northwestward. Normally, this hotspot releases pressure gradually through volcanic eruptions, most commonly through Mauna Loa and Kilauea. But lately, pressure has been building at an unusual rate. Magma chambers beneath the surface, previously stable or only mildly active, have been rapidly inflating. This sudden pressurization likely contributed to the fault ruptures that have alarmed the USGS and spurred the red alert. What makes this event particularly unnerving is the behavior of the faults themselves. Unlike most tectonic fault zones that move gradually, often over centuries, Hawaii's volcanic faults are prone to abrupt and violent shifts. These movements are governed not just by tectonic pressures, but also by the complex interplay of magma dynamics beneath the islands. As magma forces its way through deep fractures in the Earth's crust, it not only displaces rock, but can also act like a hydraulic wedge, pushing the crust apart and accelerating fault motion. With magma now intruding along several faults simultaneously, the structural integrity of large portions of the island is under threat. The most visible consequences of this geological shift are the fissures that have torn open across several regions. In Lower Puna, observers have documented cracks wide enough to swallow vehicles, stretching for hundreds of feet across previously quiet neighborhoods. In some areas, sulfur dioxide gas is venting from these cracks, a chilling sign that magma is perilously close to the surface. Volcanologists have expressed particular concern over how quickly these fissures formed, noting that their speed and pattern suggest not only a magma intrusion event, but a possible shift in the deeper plumbing of the volcanic system. This isn't just magma finding a new pathway to the surface, it's the Earth reshaping itself beneath Hawaii in real time. This development raises critical questions about what lies ahead. With magma flowing into new fractures and pressurizing new chambers, the risk of multiple simultaneous eruptions has increased dramatically. These wouldn't necessarily be contained to the familiar craters of Kilauea or Mauna Loa. Instead, they could erupt from anywhere along the newly active fault zones, including areas that have not seen volcanic activity in recorded history. If an eruption were to occur from one of these fresh fractures, it could bypass natural channels and barriers, creating unpredictable lava flows that move swiftly toward populated areas. Geological evidence suggests that such widespread rifting and fault movement could trigger a cascading series of eruptions. The island is, in effect, being pried open from within. As one fault splits and releases pressure, it can destabilize adjacent zones, encouraging further ruptures and magma surges. This domino effect poses a unique challenge to volcanologists, as the usual models for predicting eruption points and lava flow paths become unreliable when the entire system is destabilizing. Beyond the immediate geological concerns, the implications of this red alert are vast. Critical infrastructure is at risk. Roads have already been damaged or severed by fissures, isolating some communities and hampering emergency response efforts. Power lines and water systems that run along or across active fault zones face imminent failure. Evacuation routes, carefully planned for isolated eruptions, may prove insufficient in the face of multi-point events driven by fault ruptures. The USGS, along with the Hawaiian Volcano Observatory, is now in a race against time to model likely eruption paths and advise civil authorities before further escalation. The local population, though no stranger to volcanic risk, is facing an unprecedented situation. In past decades, residents could often rely on a degree of predictability from eruptions, with lava emerging from known vents and progressing slowly enough to allow evacuations. But fault-driven events complicate this equation. If lava begins to erupt from new fractures that bypass traditional calderas and cones, it could reach homes, highways, and even coastal towns with terrifying speed. Worse still, the formation of new vents near or beneath populated areas could ignite fires, release toxic gases, and cause localized explosions as magma interacts with groundwater. Scientists are also watching for potential landslide activity along Hawaii's steep volcanic flanks, especially on the southern coast of the Big Island. These massive slopes are naturally unstable, and with faults opening and shifting beneath them, there's a growing concern that large portions of the island could slide into the sea. Historical records and geological models suggest that past flank collapses have triggered devastating tsunamis. The fear now is that if these newly activated faults intersect with ocean-facing cliffs, the ground could give way in sections, plunging millions of tons of rock into the Pacific and generating tsunamis that would threaten not only Hawaii, but coastlines as far away as Japan, Alaska, and the western United States. This scenario might sound like science fiction, but it is rooted in real geological history. The last major collapse of a Hawaiian flank occurred tens of thousands of years ago. Yet the evidence of that cataclysm remains written into the ocean floor and in massive boulders thrown far inland by waves that reached hundreds of feet high. With fresh fault lines now slicing across similar terrain, the possibility, while remote, is no longer just theoretical. It is a risk that emergency planners are taking seriously as they prepare for worst-case outcomes. Even without a catastrophic collapse, the economic and environmental impacts of the current fault activity could be profound. Hawaii's ecosystems, already under stress from development and invasive species, face additional threats from lava inundation, ashfall, and gas emissions. Native forests could be destroyed in minutes by fast-moving flows. Delicate coastal wetlands, vital to numerous bird species and marine life, could be poisoned by sulfur and hydrochloric acid carried in volcanic plumes or buried under new lava fields. Tourism, a cornerstone of the Hawaiian economy, is likely to take a hit as travelers cancel plans amid reports of ground rupture, air quality alerts, and unpredictable volcanic behavior. This event has also ignited a surge of scientific interest, as geologists scramble to study the evolving fault dynamics in real time. Researchers from across the world are descending on Hawaii, joining local teams in deploying new instruments, flying drones over fissure fields, and analyzing satellite imagery. This is a rare and potentially paradigm-shifting opportunity to observe the formation of new volcanic features and to better understand how magma pressure interacts with fault mechanics. The data gathered could improve eruption forecasting models not just in Hawaii, but around the world. Still, the human cost remains at the center of concern. Communities perched along the fault lines are living under constant stress, their lives shaped by rumbling earth and the sight of newly formed chasms in their neighborhoods. Schools have been shuttered in high-risk zones, and shelters are filling with evacuees unsure when or if they will return to their homes. Authorities are urging residents to stay informed, heed evacuation orders promptly, and prepare for long-term disruption. The red alert issued by the USGS is both a technical classification and a call to action. It underscores the severity of the current situation and the urgency with which it must be addressed. As the Earth continues to split open beneath Hawaii, the convergence of natural forces, magma, pressure, fault motion, has placed the islands on a knife's edge. Whether this event culminates in one massive eruption or a series of smaller ones, the reshaping of the land has already begun. Hawaii is undergoing a transformation, one written not in centuries or millennia, but in hours and days. The fissures creeping across its surface are a reminder that beneath the serene beauty lies an Earth still very much alive, still writing its story in fire and stone. As geologists and emergency officials mobilize around the clock, what's emerging is a clearer picture of how deeply interconnected the island's volcanic system has become. The fault ruptures are not isolated anomalies, they are systemic, cascading through subterranean layers in ways that suggest a wide-scale destabilization of the region's geologic fabric. It's not simply a matter of lava reaching the surface. The structure beneath Hawaii is cracking open like a puzzle unraveling from the inside, revealing complexities in the Earth's crust that were previously only theorized. One key development is the surprising behavior of lesser-known volcanic features on the island. While most eyes typically focus on Mauna Loa and Kilauea, new seismic readings have identified increasing pressure and movement near dormant or historically quiet areas such as Kilauea and Mauna Loa. These massive mountains, although less active in recorded human history, have been seismically restless over the past week. GPS stations around Mauna Loa in particular have begun showing unexpected uplift, meaning the ground is physically rising. This change in elevation is typically caused by the intrusion of magma beneath the surface, a potentially ominous sign that deeper faults running beneath these mountains are also becoming active. This spread of pressure suggests a much broader subsurface event than initially feared. Faults aren't merely breaking along the obvious scarps, they are activating and radiating networks. A detailed analysis of earthquake distribution patterns shows that instead of following a single line or cluster, tremors are erupting in semicircular arcs. These patterns often indicate that a larger magma reservoir, possibly one previously undetected, is expanding outward, exerting force across a wide area. Such reservoirs, known as magma sills or laccoliths, are pancake-shaped chambers that press upward and outward, potentially destabilizing entire sections of crust in the process. The detection of deep harmonic tremors, another alarming signal, has intensified concerns. Unlike typical earthquakes, which occur due to sudden fracture or slippage, harmonic tremors are continuous, rhythmic vibrations caused by magma moving through conduits. These sounds, recorded by sensitive instruments, resemble low, unbroken hums akin to distant engines. Their growing presence beneath Hawaii means that magma is not only accumulating but actively migrating, carving paths through the fractured lithosphere. As these conduits expand, they bring fresh magma closer to the surface and closer to potential eruption points. Scientists are also grappling with another dimension of the crisis: the role of superheated groundwater. Hawaii's dense tropical rainfall saturates the island's porous volcanic rock, creating pockets of water that can become explosive under the right conditions. When magma rises rapidly and intersects with these underground reservoirs, the water flashes into steam. This process, known as a phreatomagmatic explosion, can cause sudden and devastating blasts that eject ash, steam, rock fragments, and toxic gas. These aren't typical eruptions. They are more like underground detonations, with no warning beyond a sudden roar and a violent expulsion of material. Recent imagery captured by thermal sensors on orbiting satellites has shown spikes in temperature not only at traditional volcanic summits, but along new fault lines, particularly in forested regions previously considered stable. These hotspots may be the surface signature of superheated rock or magma mere meters below the Earth's skin. If a phreatomagmatic event occurs in one of these locations, especially near population centers, it could produce localized chaos. Even a small blast could tear apart a neighborhood, ignite surrounding vegetation, and blanket entire districts in ash and debris. Complicating matters is the interplay of tectonic plate movement and volcanic pressure. The Pacific Plate, on which Hawaii rests, is continuously drifting northwestward. This motion grinds the island chain across the stationary hotspot, generating immense friction. While the volcanic chain has developed as a result of this movement, it also builds strain within the crust. The sudden fault ruptures could indicate that this long-building tectonic stress is now being abruptly released. In other words, it may not just be magma driving the activity, it could be a dual force of tectonic and magmatic upheaval, each amplifying the other. The movement of the faults has also altered hydrology in the region. Natural springs have begun drying up or rerouting. In the Puna district, several freshwater sources used by local communities for generations have suddenly vanished, only to be replaced by sulfurous steam or brackish water. Scientists believe these shifts are caused by subsurface displacement, fault activity changing the angle and permeability of aquifers. In essence, the plumbing system of the island is being reconfigured in real time, with cascading consequences for ecosystems, agriculture, and human settlement. In the context of agriculture, Hawaii's unique volcanic soils, typically rich and productive, are at severe risk. As fissures spread across previously cultivated fields, crops are being choked by gases and disrupted by changes in soil chemistry. Farmers have reported strange odors, dead zones where plants won't grow, and sudden die-offs in livestock likely exposed to toxic emissions. Even without full-scale lava inundation, the consequences of ground rupture and chemical release are already manifesting in declining crop yields and tainted water sources. What's even more concerning to geologists and disaster planners alike is the sudden rise of micro-eruptions, tiny, localized expulsions of gas and ash from freshly formed ground vents. These vents often appear with little warning, hissing steam and noxious vapors into the air. While small in scale, they indicate broader subsurface activity and are harbingers of potentially larger events. Some vents are now emitting measurable amounts of carbon dioxide and hydrogen sulfide, gases that can suffocate people and animals in enclosed areas or low-lying land. Public health warnings have already been issued in several regions advising residents to avoid valleys and enclosed basins where these heavier-than-air gases may settle. As government agencies expand their response operations, there's a growing realization that traditional evacuation and hazard models may no longer suffice. The random nature of fault activation means that a new vent, or even a lava geyser, could appear miles from any known risk zone. Contingency plans are being rewritten on the fly, incorporating satellite data, community reports, and real-time modeling to predict the next weak spot in the Earth's crust. Drones equipped with infrared cameras are now in the air 24/7, scouting for surface anomalies, ground deformation, and emerging hotspots. Meanwhile, the psychological toll on Hawaii's communities is mounting. Residents who lived through past eruptions are finding themselves in unfamiliar emotional territory. This time, the threat doesn't come from one mountain or one lava flow, it's everywhere. The ground beneath their homes is literally shifting, breaking apart. Children are waking to the sound of cracks forming in nearby hillsides. Entire neighborhoods are on edge, listening for the next tremor, the next explosion, or the sudden, unmistakable stench of sulfur. Churches and community centers are holding emergency meetings not only to distribute supplies, but to support mental health. Indigenous Hawaiian cultural practitioners have also stepped forward, offering guidance through the lens of tradition. In their worldview, the islands are alive, and Pele, the goddess of volcanoes, is asserting herself. For many, the ruptures and eruptions are not just geological, they are deeply spiritual, a moment of reckoning and transformation. Ceremonies are being held at the edges of newly opened fissures, chants offered to the land and sky, not to halt the eruptions but to acknowledge them as part of Hawaii's ongoing creation story. In this sense, the island is not being destroyed. It is being reborn, though in a way fraught with peril and uncertainty. International interest has reached a fever pitch. Geological societies from Japan, Chile, Italy, and Iceland, all nations with their own volcanic risks, have sent specialists to study the fault systems now opening across Hawaii. The event is being hailed as one of the most significant natural experiments in modern volcanology, a live, unfolding example of how a complex volcanic and tectonic system behaves under acute stress. The data being collected here may influence not just local policy, but global preparedness for similar crises in volcanic regions around the world. In the midst of all this, another threat looms, one tied not to lava, ash, or fault ruptures, but to the ocean. Oceanographers are closely monitoring the seafloor around the Big Island for signs of bulging or displacement. Underwater pressure sensors have picked up minor anomalies that suggest the volcanic deformation may be extending offshore. If magma begins pushing into the seabed, it could trigger underwater eruptions or create hydrothermal vents that alter marine ecosystems. Worse, a sudden underwater explosion or landslide could generate tsunamis with little warning, slamming into the coastlines of Hawaii and beyond with devastating force. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on USGS issuing red alert after Hawaii's fault splitting? We want to hear from you. Thank you for watching and see you next time.